Well, let's go ahead and look at the test review. Um, this video is here to help you guide you in the right direction. I'm not going to give you the actual answers. You are going to have to type in the numbers yourself into the calculator. All I'm going to do is just set you up and just kind of help prepare you. Again, if I was you, I would probably go ahead and use my formula chart with me while I'm answering this, because when you come up to the school to take the test, this is all you're going to have. This and your calculator. Okay, so I would practice by using this. This video, again, like I said, you don't have to do the test review, so it's not mandatory for you to watch it or mandatory for you to do this. It's up to you. It's extra bonus points onto the test. Now, the review needs to be turned in before you take the test. So that means if you forgot it in your car, and you forgot it at home, or something, it disappeared, I'm so sorry. I'm not going to accept it after the test is given. So make sure you have it to turn in on time. Now, the first thing is on this front page, I told you in our Teams meeting for class that we were scratching this out. I took this equation out and I forgot to take it out of the formula chart. I'm sorry, out of the test review. Okay, so go ahead and get rid of that. What do they stand for? So what does an omega sign stand for? This stands for angular speed. And the SI unit for angular speed, do we remember? It's rads per second. Okay. What is this symbol? That's a theta. What does it stand for? Angular displacement. And what is the SI unit for a theta? It's going to be a rad. And remember, if I was you, I would make sure that my calculator is in radians, not degrees. Okay? And so I know you can finish this up. That last page of our notes should be able to help you answer all of this. Show the direction of a circle moving in the positive direction. Positive direction would look like this. What about show the direction a circle will be moving in the negative direction? In that case, it would be turning this way, to the right. To the right is negative, to the left is positive. Then I'll come back to those in just a moment. It says here, go ahead and define radian. You can definitely use your notes, and it's on page 1 in your notes. It was also, hint, hint, the question on our quiz. So you can go to the quiz and pull that up, and that was, I think, one of the it might have been the last question on the quiz. How many radians fit in a half of a circle? So if we're talking about a half of a circle, we end up with 1, 2, 3, and then a little piece extra. Remember that? So it's 3.14. And how many pi radians are in this? So in 3.14, we end up with 1 pi rad. How many radians are in a full circle? Well, in that case, it's 6.28. How many pi rads are in this? Well, that's 2 pi rad. What is the formula for calculating the circumference of a circle? 2 pi r. If a car circles a perfectly round track 10 times, how many pi rads did it transverse? So if it went around 10 times, and I'm just, going to draw this out for any of us that are visual. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There goes the 10 times. Each circle contains 2 pi rads, and they want to know how many pi rads it transverse or travel through. So this one has 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. Right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 pi rads. Now, we are going to look at a motorbike is moving in a circular track that covers the arc length of 20 meters. Arc length is S for the symbol. Meters is the perfect SI unit. Do not convert it. If the track has a radius of 12 meters, lowercase r, from the center, find the angular displacement, question mark theta. On your formula chart, angular displacement, and right here, angular displacement equals arc length divided by radius. So theta equals S over R, or 20 divided by 12. Okay, you're going to get your answer. Your SI unit for a rad, for a theta is a rad. All right, let's keep going. A girl is sitting on a merry-go-round which moves through an arc length of lowercase s 2.5 meters in 27 seconds. T for time. If the merry-go-round has a radius of 1.5 meters, r, what's the girl's angular velocity? Question mark. We're looking for the velocity. So in this case then, we have our tangent velocity, which is 2 pi r over capital T. We also have our angular speed, which is our angular displacement over time. Okay, angular displacement over time. And then we have our third equation, which is the tangent velocity equals radius times the omega, which is angular displacement. Okay, so let's look to see. Here is V sub t equals 2 pi r over t. We have omega equals theta over time. Or we can use V sub t equals r over angular displacement. Which would be multiplied. Sorry, not divide. In this case, we're going to have to go ahead and do a two-step problem. And step number one is going to be our angular displacement equals S over R. Okay, we have our S and we have our R. Our S is 2.5. Our radius is 1.5. You're going to end up with the number, which is going to be your rad, which is angular displacement. Now that I have my theta, I'm going to go ahead and use angular speed to solve for it, because remember, velocity and speed are used interchangeable. So let me go ahead and put a number 1 over here. And number 2 is going to be omega equals theta over time. My theta is this number right here. Plug it in over here. My time, they told us, was 27 seconds equals blank rads per second. And that's my answer. And again, remember, I told you I'm not going to solve it for you. I'm just going to set it up. You need to do the steps and solve it. Okay? Let's keep going. It says that a ball is being spun with a string that has a tangent velocity, so v sub t of 17. If the centrifugal acceleration is a sub c 28 meters per second, how long, question mark, is the string? Radius is what we're looking for. Okay, well, in this case, let's see what we can use so we can solve for this. We can use Vt equals 2 pi r over capital T. We have the Vt. 2 is a constant. Pi I know is a constant. R is here. I don't have the capital T. So it looks like that's not going to be a good equation to utilize. Okay? If we keep on looking, they did give us our centrifugal acceleration. And the centrifugal acceleration equals Vt squared over r. Why don't we use that equation so that way we can solve for r? First thing, I'm going to go ahead and put this into the triangle. Vt squared over r and AC. I'm looking for r, so I'm going to rearrange this to r equals Vt squared over acceleration. Let me go ahead and plug those numbers in. So 17 squared over 28 equals the radius. Okay, so hopefully that helps you out. I'm not going to do all of it. I'm only going to kind of like skip around here and there as I'm going through it. But before I turn the page, let me go ahead and get the protractor. Some of us are still kind of iffy and still kind of stressing because we're not too sure about the protractor. Okay, now if you don't have a lot of space, the suggestion is that you extend that space out. So I'm going to extend it. I was trying to find a piece of paper so that way I can extend it out. Okay. Now, while I'm extending it out, I'm going to obviously use this. I like to have this y-axis to come all the way up to the 90. It's not, so let me come over here and let me extend the y-axis to help me. There we go. And I'm going to go ahead and extend this line too. Let me make sure I'm on the line. So there we go. Let me line up. This little circle is going to go right here in the center of my circle. Okay, right here, smacked up in the center. This line right here, and including all the way to here, is going to line up with my x-axis, and my y-axis is going to line up right here where this number 5 is, like this part, all the way up to the 90. So let's line it up first before I go any further, just so that way I can make sure I have everything, hopefully. I need to line this up. Here we go. Let me scoot this over so you can see it. So 180 degrees is a half of a circle. Okay, but if I want to work my way backwards this way, this is 0, this is 10, this is 20. Well, you can see that my line doesn't go to the 20. If it extended out, it should come over here to this one. So the number right before 20 is 19. So this theta is 19 degrees. Okay. I'm looking for the radian too. So in our formula chart, you're going to get your degrees right here where it says it. And you're going to multiply it by pi and divide it by 180. So 19 times pi divided by 180 is going to give you your answer right here. Okay? So hopefully that helps out. You need to practice using the protractor. Okay? Whether you use a printed out one or you go to the Dollar Tree or Dollar General and go buy you one. Okay? But you're going to need a protractor. You're going to need a protractor again for the semester exam. Other than that, if you want to use my protractors, no problem. That's completely okay. Okay? So let me go ahead and move the protractor so we can turn the page. And we're going to keep going. Okay. So now let's go ahead and let's look over here. The blade of an electric blender is whirling with an initial angular velocity of, so VI, because I used the word VTI, right, because that's my initial, while the puring button is pushed. When the blend button is then pushed, the blade accelerates and reaches a velocity of, so final velocity, VTF, and it took 1.2 seconds to reach this velocity. What is the angular acceleration of the blender as it's sitting and it's changing from the puring to the blend? Well, as we look at this equation over here, I thought I told us that there were two acceleration equations that we can use. I wasn't planning on using it, and now I see it's over here. Let me go ahead and send a message to everyone. VT squared over R is the equation that we're using. There is another acceleration equation, like when we talked about linear motion in the first semester, which was final velocity minus initial velocity over time. There's one very similar to this that's talking about circular motion. Okay, but in this case, though, I took it out of our notes, and I guess I did not know that this was part of it. I didn't read the whole question. So I'm definitely going to send out a message to everyone that this is not expected of us. And if there is something like this on the test, it is not expected of us because I took it out of our notes. So I will definitely make sure I let everyone else know in the teams. It says here, many microwaves ovens rotate the food as it cooks. A plate is put on the microwave oven and it's starting from rest and accelerates to an angular velocity of 44 rads per second in 5 seconds. Calculate the angular acceleration of this plate. Well, again, they're using the word angular because we're moving in a circle. Velocity. I understand that our velocity, when we do this equation over here, it is in meters per second. But when we do this equation, it is in rads per second. But speed and velocity are used interchangeable. So in this case, they're just using it interchangeable. So for our acceleration equals VT squared over R. And this is the equation now that needs to be like this. Here it is again. I was not expecting this on here. I'm glad I'm going through this right now. And let me tell everyone on teams that we are not going to look over number 13 and 14. I took those off of our notes. I actually took 2 equations off. That was one of them, and torque was the other one. I apologize for that. Let's keep going. I'm glad I'm going through it with you here so that way I can see what is on here and what is not. A tire rotates 26 times in 2 seconds. So this is turns and this is time. If it is experiencing a tangent velocity of VT 120 meters per second, what is the radius? Question mark R. Well, VT equals 2 pi R over capital T. They didn't give us capital T, period, but we can solve for that. So I'm going to come over here and I'm going to say capital T equals time over the turns. And you're going to get a number. That's going to be your seconds. That's not my answer. I'm looking for R or for radius. Oh, I like this equation or this problem. I'm going to plug this into the triangle. 2 pi R is at the top and capital T is at the bottom. And let's put VT in there. What am I looking for? I'm actually looking for the R, but this comes like together as one group. So 2 pi R equals VT times period. Or 2 pi R equals 120 times whatever your period number over here is going to go over here. Okay. Now, let's go ahead and do our algebra. If this was me, I would divide by 2 pi. To cancel that out, I would divide by 2 pi. And I would say that R equals 120 times period over 2 pi. Okay, so R is in meters. And that should be your answer. Okay, that was a good question. A large wheel rotates with a radius of 4 meters. Now, what happens to the acceleration if we were to increase the velocity by 2 times? Okay, well, they gave us the radius of 4. So in this case now, let's go ahead and let's use centrifugal acceleration equals VT squared over R. Okay, so let's use simple numbers. Let's simplify this, but we have to do it 2 times so that way we can see what happens when you increase it. So let's do 2 squared over 4. Okay, 2 times 2 is 4. 4 divided by 4 is 1. That was the first time. To compare, you have to have 2 numbers. So let's do it again. We are going to double the velocity. So instead of it being a 2, we're going to double it to a 4. So 4 squared over, and we're going to leave the radius alone, which is 4. 4 times 4 is 16. All right. And so now you can come over here and 16 divided by 4 equals 4. So from the number 1 to the number 4, what happened? It increased by how much? Well, if you're not sure, then you're going to get the bigger number into your calculator, which is 4. And you're going to divide it by the smaller number. And I know this is simple, but I'm just showing you how you're going to do it with whatever other numbers they give you. So the big number divided by the little number equals 4. Now, it increased by 4 times the amount. Okay? Here's my shortcut. What am I going to do? I'm going to increase by 2 times the amount. And what am I changing? I'm changing the velocity. Velocity, you can see, is a squared value. So I'm going to get this number times my square. 2 times 2 equals 4. That's my shortcut method. Okay? The long method is doing it 1, 2 times and looking at it. Okay? So it increased by 4 times. What's going to happen to the acceleration if you half the velocity? Okay, so a sub c equals vt squared over r. We're going to leave radius the same, but we're going to half it now. So let's go ahead and we're going to keep it with simple numbers. 2 squared over 4 equals 1, because we know that. Now, and that's going to be my first problem, my second one, instead of it being 2, I'm going to half it. So 2 divided by 2 is 1 squared over 4, because we're going to leave 4 the same. So 1 times 1 is 1. 1 divided by 4 is 0.25. Okay? So how much did it decrease? Well, again, let's go to the calculator. 1 divided by 0.25, get the bigger number first, it changed by 4. That is my amount value that it decreased, right? Because my first number was 1, my second number was 0.25, so it decreased by 4 times the amount. How did I figure that part out? The bigger number first divided by the smaller number, which was 4. Okay, remember in class I told everyone that we are definitely not doing this, so I apologize. You should be able to answer this. Here's another question here. I'm going to let you solve for that one on your own. I'm going to send a message out to everybody regarding 13 and 14. Hopefully you're able to finish this review. Just a little help to keep your mind thinking about it until you take the test, which is either going to be Wednesday or Thursday of next week. Okay, have a great day.